Hello students, welcome to experiencetutor.com. Today's lesson is class 11th chemistry, some basic concepts of chemistry, part 8.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Let us solve few more problems in chemistry. Question number 1. How many gram of oxygen is required to completely react with 0.2 gram of hydrogen to yield water? Also calculate the amount of water formed. Molecular mass of hydrogen is 2, oxygen is 32. To solve this question, first we will write the chemical equation. So the valid chemical equation will be two H2 plus O2, 2 H2 plus O2 is equal to, which will give 2H2O. So 2H2 we can write it as 2 mole O2 we can write as 1 mole, water we can write as 2 mole. So 4 gram, oxygen will be 32 gram and water will be 36 gram. Now 4 gram of hydrogen is require oxygen is equal to 32 grams. So we can write in this way: 4 gram of H2 require oxygen is equal to 32 gram. Then 0.2 gram of hydrogen will require oxygen is equal to 32 upon 4 into 0.2, which is equal to 1.6 gram. Again 4 gram of hydrogen produce water is equal to 36 gram. Therefore, 0.2 gram of hydrogen will produce water is equal to 36 upon 4 into 0.2, which is equal to 1.8 gram. Limiting agent. Let us consider a reaction where combustion of hydrogen is taking place. So let us consider, say, 2H2 plus O2 gives 2H2O. Suppose 2 mole of hydrogen and 2 mole of oxygen are taken from a reaction for a reaction. Uh, it follows the equation and it produces 2 mole of water. The amount of product obtained is determined by the amount of reactant that completely that consumed in the reaction. Here H2. The reactant is called limiting agent. Thus, limiting agent or limiting reagent may be defined as the reactant which completely consumed during the reaction. So, uh, therefore, limiting reagent is defined as the reactant which is completely consumed during the reaction. In our case, it is H2. Next problem is how much magnesium sulfide can be obtained from 2 gram of magnesium and 2 gram of magnesium and 2 gram of sulfur by reaction. So Mg plus S gives Mgs, which is the limiting agent. Calculate the amount of one of the reactant which remains unreacted. Mg is equal to 24, S is equal to 32. To solve this problem, first we will convert the masses into mole. So 2 gram of magnesium is equal to here there is some mistake in the problem. So let us first this is written incorrectly here also. So first we will convert this masses into mole. So 2 gram of magnesium, 2 gram of magnesium is equal to 2.0 upon 24, which is equal to 0.00833 mole of magnesium. Similarly, 2 gram of sulfur, is equal to 2.00 upon 32, which is equal to 0.0625 mole of S. From the equation Mg plus S gives Mgs, it follows that 1 mole of magnesium reacts with 1 mole of sulfur to give the product. When we are given more moles of magnesium than sulfur, therefore sulfur is the limiting agent. From equation, 1 mole of sulfur gives 1 mole of magnesium sulfide. So 0.0625 moles of sulfur will react with 0.0625 moles of magnesium to form 0.0625 of magnesium sulfide. So we can easily write here 0.0625, again 0.0625, and this 0.0625. Now molar mass of magnesium sulfide is 56 gram. Now molar mass of magnesium sulfide is equal to 56 gram. Mass of magnesium sulfide formed, so mass of magnesium sulfide formed is equal to 0.0625 into 56 is equal to 3.5 gram of magnesium sulfide. Mole of magnesium sulfide left. So mole of magnesium sulfide left is equal to 0.0833 0.0833 minus 0.0625, which is equal to 0.0208 0.0208208 mole of Mg. Mass of Mg left unreacted. Now mass of Mg left unreacted unreacted is equal to moles of Mg into molar mass of Mg. Moles of Mg into molar mass of Mg, which is equal to 0.0208 into 24 gram of Mg, which is equal to 0.4992 gram of Mg is equal to 5.5 gram of Mg. Our next question is calculate volume of carbon dioxide produced on heating 10 gram of limestone at S.T.P. Here we have to write the equation as CaCO3 gives CaO and CO2 gas. Here CaCO3 we can write it as 100 gram. CO2 we can write it as 1 mole is equal to 44 gram is equal to 22.4 liters. Now 100 gram of limestone gives 100 gram of limestone gives CO2 is equal to CO2 is equal to 22.4 liters. Therefore, 10 gram of limestone will give CO2 22.4 upon 100 into 10. On solving, it will give 2.24 liters. Our next question is calculate the number of moles in Na2SO4 produced from 1 mole of sodium hydroxide, NaOH. So first we write the equation two NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Now, from the given equation, we can write 2 mole of sodium hydroxide gives, therefore, here 2 mole and Na2SO4 is 1 mole. Therefore, we can write 2 mole of NaOH gives Na2SO4 is equal to 1 mole. Therefore, 1 mole of sodium hydroxide gives, therefore 1 mole will give 1 upon 2 moles, that is half mole of Na2SO4. Our next question is calculate mass of carbon dioxide produced by heating 40 gram of 20% pure limestone. So our equation will be CaCO3 which will give CaO plus CO2. Here we can write 1 mole, here we can write 1 mole. Here we can write 1 mole is equal to 100 gram. Here we can write 1 mole is equal to 44 gram. Now we can write pure CaCO3 is equal to CaCO3 is equal to 40 into 20 upon 100 which is equal to 8 gram. From the equation we can also write 100 gram CaCO3 gives CO2 is equal to 44 gram. Therefore, 8 gram will give 44 upon 100 into 8 which is equal to 3.52 gram. How many moles of lead nitrate is needed to produce 20 224 liter of oxygen at NTP. Here, first we have to write the equation. 2PbNO3 gives 2PbO plus 4NO2 plus oxygen. Now 1 mole, we can write 1 mole or 22.4 liters O2 at NTP is equal to 2 mole of lead nitrate. Therefore 224 liter. Therefore 224 liter O2 at NTP will give is equal to 2 into 224 upon 22.4, which is equal to 20 mole of lead nitrate PbNO3 whole 2. Our next question is calculate the amount of 50% H2SO4 required to decompose 25 gram of marble calcium carbonate. We'll start with writing the relevant chemical equation for according to the question. CaCO3 plus H2SO4 CaSO4 plus H2O plus CO2. So CaCO3 is 100 gram, H2SO4 is 98 gram. 100 gram of marble requires 98 gram of H2SO4. Therefore, we can write 100 gram of marble required 98 gram of H2SO4. Therefore, we can write 25 gram of marble require 98 upon 100 into 25, which is equal to 24.5. gram of H2SO4. But H2SO4 provided is only 50%. So, but H2SO4 is only 50%. Therefore, uh, so the amount required will be amount. Therefore, the amount required will be 24.5 into 100 upon 50 is equal to 49 gram.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.